Okay, so in the last class, as you remember, we did the physical design of IoT, and we talked about the MQTT protocol. So we discussed about an implementation in the ESP board, the MQTT protocol, how it can be implemented. So today, I think we will move forwards from that point, and we will talk about the MQTT quality of service. So MQTT protocol is used to ensure the reliability of the data transfer, and therefore we need to uh, maintain the connection with the connected devices. From the MQTT broker to its connected devices whenever there's a loss of connection. So therefore, quality of service is defined for the MQTT protocol. So there are three basic levels of quality of service levels. So the reason that we require that is because we need to maintain the reliability of the communication. That means we can't lose the data packets transmitted from the IoT device to the MQTT broker, and from the MQTT broker to the other client devices. So in order to make sure that we don't lose the connectivity with the devices and we don't lose the data packets, we define quality of service levels for MQTT. So basically, there are three types of quality of service that we define in standards, and that are 0, 1, and 2. So like MQTT like protocol, MQTT protocol based communication can face a loss of connection in a situation where we have like dynamic clients, right? So for example, let's consider a scenario where we like publish information in the cloud, right? Assume that there are some sensors from which we are collecting data, and we are publishing that information in the cloud, right? So in the cloud, we have the MQTT broker. However, the client which is subscribing to that data is a dynamic device. So that device is moving, and so at places where it goes under tunnels, or when it's going inside buildings, so through areas where there's some interference, it might not have the direct communication link with the servers or connection base stations, right? So therefore, it might lose the connection, and it might lose some data. So in that case, once the communication link is broken, then we call that like loss of connectivity. So in that case, we need to resend the data, and we need to ensure that we have sent the data required by the device. So the level of sending the data is defined by this QoS levels. So we have the method of functioning for each QoS level. So the QoS 0 is the lowest quality of service level. So that means in that case, we actually don't have a reliable communication level. We don't have a good quality of communication. So the communication is unreliable. So the reason is that the message is sent, but reception is not sure. That means that the sensor is making measurements and it is publishing to the MQTT broker. However, the sensor-based embedded system, it does not expect an acknowledgement from the MQTT broker. So in this case, the sensor does not know whether the data has been reliably sent to the MQTT broker or not. So in cases where we lose the connectivity, we might lose some data in this scenario, right? However, this is also used in situations where we don't need all the data, right? If we lose one or two data, it's okay, right? So there are some scenarios like that where we don't need all the data which have been collected by the sensors, but it's okay to lose a certain percentage of data. So in such situations, this is a good quality of service that we can define for the communication, and that we can define in the protocol. So so this QoS0 is used for frequent updates. Once we have very frequent updates from the sensor, then we don't need a very high level of quality of service, and therefore we will be happy with QoS equal to 0. So very frequent updates means, like, for example, if the sensor is sending data every 1 second, or every 5 seconds, then just losing 1 or 2 data or several, percentage of data might not really affect the overall performance analyzed at the MQTT broker and also at the client device. At the client device, they might not even notice that they have lost some data, because it is just losing some data per, like, in some for some duration of seconds. So since the data keeps coming, the new data will replace the lost data. So the customer will not notice that data has been lost. So in QoS1, quality of service 1 level, it is much more reliable than the quality of service 0 level. And it is using an acknowledgement method to ensure the quality of service. So a message is sent by the sensor, and an acknowledgement is received. So in this case, like sensor-based embedded system, it is waiting for an acknowledgement from the MQTT broker. So in this case, we are talking about not that frequent updates. So the sensor is sending data not that frequently. So therefore, there is some time interval where the sensor based system is waiting for the update or acknowledgement from the MQTT broker. In this case, we are actually talking about reliable communication. So if the acknowledgement is not sent on time, the sensor-based embedded system can send duplicates of the same data they have sent earlier. So if the acknowledgement is expected to come after a certain time period, and it is not received at the sensor-based system, then the sensor-based system sends the same data another time, which is a duplicate of the data. So in this case, duplicates can occur, so which is a wastage for the communication network. However, we can ensure that MQTT broker will receive the data. So until we get the acknowledgement, we will send duplicates of the data. So in this case, it is good, but sometimes if we don't receive the acknowledgement on time, we will have to send duplicates. So there's the third quality of service level, which is the QoS equals 2, which defines the quality of service to have 4-part verification. So in here, we are talking about a very important data communication. So if the sensor based embedded system send some data, that data must be received by the MQTT broker and it will only be, received, sent once and received once. So therefore, actually, in here, like MQTT server client is sending the data, and the MQTT broker is sending like acknowledgement 2 times, right? So actually, this is known as 4-part verification. So in that 4-part verification, 4 types of messages are used. So first, like the client is sending the data, which we call as the publish message, right? It is known as publish message. And then we have publish received message. That means the MQTT broker is saying that I have received the message, and that message is sent using a message type called publish received. So it is known as pubrec, right? So pubrec message is sent. And then we have from the sensor-based embedded system another message saying that publish released, which is known as rel, which means that it is not going to publish that same data again. And then MQTT broker is saying once it receives the third message or the second message from the client, the MQTT broker is sending another message saying the publish complete. That means the data transaction has been completed fully. So um, so that is how the QoS2 is done, where the data is sent by the sensor, and the MQTT broker is acknowledging that data using this acknowledgement message, which is given a specific name, pubrec. And then once that acknowledgement is received by the sensor is saying, I'm not going to send that data again. I'm not going to publish that data again. So that message, it is sent through a message type called pub release. And then once the MQTT broker receives that, it knows that, okay, the client is not sending that same data again. So now it knows that the data has been received and the total process has been completed. And therefore, that MQTT broker should send the publish complete message. So that message is sent to the client. So so there's 4-part verification in this method, and this kind of method is used to ensure the transmission of very important data from the sensor based embedded system to the MQTT broker. So in this case, we have higher reliability, right? That is the advantage of this level. However, we have higher latency, and also the network traffic is higher. So actually, to send the data, we require to send one data, we require 4 messages. So we are adding a lot of messages to the network, and also in order to, like, for the one transaction to happen, we take a lot of messages, and that causes higher latency in the communication. So therefore, we call this actually reliable communication, but it is not practically feasible for all communication systems. And it is said that in industry, this standard quality of service is actually QoS 1, because it is actually sufficient for most of the applications, right? So the QoS 1, it is having reliable like communication, right? It is giving acknowledgement back to the sensor, right? So therefore, we can have some kind of reliability there. But again, in that case, even though we have the acknowledgement, sometimes we might not get the acknowledgement back from the MQTT broker, right? If we get a delay or something from the MQTT broker, then this person who's transmitting the data will resend the same data again and again until it receives an acknowledgement, right? So therefore, duplicates can happen in this scenario. right? So in here, actually, that is the advantage of having QoS 2, whereas where the sensor-based system sends only once the message and it waits until a acknowledgement is coming, right? Until that acknowledgement is received, then the sensor is not sending any data again, right? So that is why QoS 2 is more reliable than QoS 1, right? So yeah, so that I hope I'm answering the questions of the questions asked in the chat. So the use of having QoS 2 is to make sure that we don't send the same data again and again, the duplicates. So we are waiting for the acknowledgement in that case, and we are doing like multiple message sending there. So the advantage there is anyway not sending a duplicate. So what is the use of having pubrel and pub complete even after pubrec verifies that the data has been received? So the pubrel and pub complete, they are used to say that I'm not going to publish the same data again, right? So I'm not going to send a duplicate of that same data again. So it is a message that MQTT broker will, pubrel is used by the MQTT broker to know that um, the sensor will now not send the same data again, right? And also it has received MQTT broker's message, right? Now, I hope that is clear to you, because like now this MQTT broker also needs some understanding acknowledgement from the MQTT client. So that acknowledgement is coming from the pubrel message, right? So that it has received the acknowledgement from the broker, right? So once like if for example, if the client does not receive this message, there's a chance that the sensor might publish again some data, right? But in here, the sensor is waiting for this second message, or the message from the MQTT broker pubrec, this one, right? And once it receives, it will let the MQTT broker know, I'm not going to send that same data again. And then with that data, MQTT broker is going to know, okay, the message I have sent has been received by the client, and now the process is finished. Now it is not going to send the client is not going to send the same data again. So now the process has been completed. I have received the data, and therefore I will close down the communication. So in order to close down the communication, again, the MQTT broker is sending this pubcom message, which says that the total communication has been closed. So this is only talking about one data only that we are sending, right? I hope it is clear to you. Right, we are only talking about the communication of one data packet, for example, from the client to the MQTT broker. So we want to make sure that it has been transmitted reliably to the MQTT broker, and then that the acknowledgement has been received by the client, and likewise, we want to make sure that both these messages have been transmitted reliably. So I hope it is clear to you. If it is not clear, you can let me know. Right. So if you want to know more about this MQTT protocol and its like details, you can go to this website. You can get more information about it, right? And I think it has a lot of data, so you can actually read about it. You can get to understand how MQTT works and so on. And it's all, specifications are there. and its advantages are there, and so on. So how it's applied in the different areas are given there. So you can search from this website. Okay, so we will start talking about the CoAP protocol, I think, today. So we need to talk about the CoAP protocol. So let me search for it. Yeah. So as the next important protocol in IoT systems, we have the CoAP protocol, right? So with respect to IoT, right? So yeah, so actually in communication protocols, right, it's very important for us to maintain quality of service, right? So quality of service is used to ensure that data has been like reliably received at the receiver, and therefore actually in communication networks, basically in general, uh, quality of service is a metric that is defined for the systems. So different like methods are there to measure the quality of service, and different concepts and theories are there to measure the quality of service, and especially in telecommunication field, we have quality of service as a metric to measure the communication reliability and the latency and so on. So that is defined for different communication uh, systems. So we have in telecommunication field, we have standard organizations which define the quality of service. So as you saw in MQTT, we have quality of service of level 0, 1 and 2, and so such levels are defined. So likewise we have similarly for our telecommunication networks, right? For the communication that happen from our devices to the base station, and from the base station to us. So they can monitor the level of communication using this quality of service. So they can define the connection level using this quality of service metric. So in order to maintain a higher quality of their service, they are actually defining this. So it is defined in the standards. So it is based on the standards, and the way they have defined it, only we can actually define the quality of service. Right. So the application of MQTT. Quality of service. So as I said before, once we have clients who are working dynamic areas, who are moving from one place to another, like in vehicles, or in if we are talking about robots, or if we have other any kind of moving, like even people who are moving from one place to another, if they are connected to the cloud, or if they are connected to the MQTT broker, then the data that is coming from the MQTT broker will not get uh, lost if we use this quality of service levels, right? If we are using quality of service 1, for example, we will always try to get back the information that we want um, by maintaining that acknowledgement. Making sure that we receive an acknowledgement from the from our broker, right? So likewise, we can have real world applications where we require like data constantly about a remote location, right? For example, if you are using MQTT protocol to like monitor the like conditions in your home or in your industry, in your factory, like if you are going to remotely monitor from a like a remote location, right, you will not lose the data if you have a good quality of service. So if you are maintaining quality of service at least 1 or 2, you can make sure that the data is not lost, right? So if you are maintaining QoS 1 0, then you might lose some data, right? So that is the difference. So in here, we'll be continuing our like discussion about the protocols in IoT networks, and we will move ahead with the now with the MQTT, and we will go and study about the other protocols that are widely used in IoT networks. So we have other protocols which are known as CoAP, which is Constraint Application Protocol, and HTTP and WebSocket protocols. So HTTP, I think it is widely used not only in IoT networks, but also in computer networks in general. And it is used to access websites and web services. So we'll be talking about HTTP first, and then we will talk about CoAP second. The reason is that CoAP is built on the foundation of HTTP. So therefore, we need to know how HTTP works, and then we will learn about then we need to learn about CoAP. We will go ahead. So HTTP refers to Hypertext Transfer Protocol. And HTTP is used widely to access websites and web services. So we can access Google, email, online shopping, social media, and other types of web-based applications using HTTP protocol. So once we are accessing those websites, we can actually see what kind of protocol is used to access that website, for example. So the HTTP protocol defines the set of standards about how the web servers and clients should exchange data over the internet. And it works over TCP protocol. So it is something to remember is that the transport layer protocol that we use depend mostly on the application that we are using, right? If the application is to access Google or email, right, then we need reliable communication with the website, right? So therefore, we need to use TCP protocol, which is a connection oriented protocol. So that means TCP protocol is establishing the route between the destination and the source and the destination, and then they are sending the data from the source up to the destination, right? So in this case, we are actually reaching very high reliable data communication from the source to the destination. So once we are actually accessing some personal, information which is available in our email and in online shopping, in banking, for example, so in banking apps, right? So in those cases, we need to use HTTP protocol, which is very reliable communication protocol, which do not make data loss. In such cases, we use TCP protocol as the transport layer protocol. And in this HTTP protocol, we use request response method. So we request for some resources from the server, and the server is responding back with an acknowledgement, and then the communication is ending. So we can actually access different web services using HTTP protocol. We can access websites like online shopping websites or Google email, and then we can access video servers. We can access message servers, and depending on the application, we can access different types of servers. So another thing is that HTTP uses different methods to request resources. Right. So in order, I mean, it uses different functions, which we called as request methods, HTTP request methods, to request data from a server, right? From a certain URL, right? We are requesting data, and for that we are using the function get. And then if we want to post something or create new data in the server that we are accessing, we use a function called post. And then we are using a function called put to update the existing data in the server, right? And then we can use the function delete to remove the data that is available in the server. So these request methods are the main methods of HTTP. There are other methods also in HTTP. So basically, we will be going through these methods, which are known as the basic methods of requesting resources from a server using HTTP. So let's consider an example scenario where we are using HTTP protocol to update temperature and other sensor data into a website, right? So first we need to connect our ESP32 or our embedded system to the Wi-Fi router. We need to connect with the router, and then from the router, router needs to connect to the internet, right? Once the connection with the internet is made, then we are using the HTTP protocol to access the application, right? So the application is the example domain.com website. So we use the HTTP protocol to access that website, and we use the request method post to post the sensor data in the website, right? So it is stored in the server. So we can use this method to update data in the server. And after that, the server will show the data using other tools like PHP script, and it will use database management tools like SQL to store the data in a convenient manner, such that the data does not get lost and it is organized. Then the data will also be visualized as plots and graphs at the user interface, and enable the customer to visualize the data that is entered into the system. So then we are also going to talk about HTTPS, which is the secure version of HTTP. So only the letter S is added. So it shows us that HTTP, more secure HTTP is used, right? So I will first actually show you how we can actually see HTTP protocol in use in websites such as Amazon, for example. So we will go to the Amazon website, right? Right. So once we go to the website, we can go to the inspect option, right? We can right click, go to inspect, and in here we have like a black, uh, I mean, uh, interface where we can select network. Once we go to network, we can actually see the protocols that are in use, right? We can see that in here. right? We can go to network, and in here we can see under general, under the request URL, we can see HTTPS protocol has been used to request this URL. And then post method has been used to use as the request method, right? So once we actually type something in here, right? We can type ESP32, and then you can see a lot of links are appearing. Most are having the type of get. Actually, post is there, but get is there because we are trying to get information about a certain resource that we require. So we typed ESP32 and we need to get information. So therefore we have get requests in most cases. Right, post request is also there in cases where the server is posting some data onto the website, right? So we can click these links and we can see now post request method is also used by the Amazon server itself to create new data in the website. So likewise, we can actually go and inspect the network protocols used in the website by clicking right click, and you can inspect, and you can go to network, and then you can see these data. Right. Apart from that, in here it is mentioned HTTPS, not the HTTP, but HTTPS. So it means it is using secure HTTP version to access this resource, right? So we will now talk about HTTPS protocol, right? So HTTP HTTP S protocol is the more secure communication protocol than HTTP, right? So the HTTP is right. So once we are sending, once a client, right? Let's say there's a client, right? That client is sending some data from one destination, right? It is connecting, he is connecting to a router, and then there are some routers in between, and after that, the data is received at the destination server or some kind of device. So once the data is going through these these routers are connected to servers, and the people who are accessing these servers can get the data that you're sending through, by accessing the server, right? So if there's a person who is working at the server, that person can get your information by accessing the server. So if your information is in human readable format, then that person uh, should uh, I mean if this data is sent in the human readable format, then this person can read the data in that packet, right? So in HTML, XML, and JSON, the data is written in human readable format, right? If this is sent in ABC, if this person is sending some kind of a data, right, in a human readable format, in some kind of a letter or word, right? Let's say he's sending the word cat. So if he's sending the word cat as cat, then this person will be able to read it as cat if it is sent using HTML, XML, and JSON formats, right? So therefore, in this case, this is not secure. The data transmission is not secure. The person who's in between can erase your data and modify your data, right? It can, that person can totally erase the data that you're sending, and also that person can just modify the data and send something else, right? He can send some other message, so the destination will get some wrong messages. So therefore, this is a threat to the the network, right? So this is a threat. So this person is known as hacker. We call hackers and jammers, right? So we call these persons like people who are a threat to the network security. So now actually we have like a separate field called cyber security, right? In order to ensure the security of the network and application, right? Application security, the cloud security, right? Device end security, device on device security. Likewise, we have different areas, right? So under that we have network security. So network security engineers are required now to ensure the security of the data, right? Because people are accessing and modifying and deleting data in the network. So in that case, we have used network engineers to secure the data, right? So so once this kind of situation happens, we can't guarantee the data transmission, right? So in order to guarantee the data transmission, we need to enhance the performance of HTTP protocol in terms of security. So we are adding HTTPS feature, I mean a security feature, and we are calling that protocol HTTPS, right? So once we actually go Google, in the Google trend, once we check the popularity for HTTP and HTTPS protocols, we can see the HTTPS protocol has more popularity than the normal HTTP protocol. And also it is said that Google is using most of the time HTTPS based web services into account, and it is not allowing HTTP only based protocol communications. Yes, so we are going to talk about how the security is added by the HTTPS, right? So actually this person asking about after going to the network tab, what should we select? So earlier I think I went to the network tab and then I went to all in there. So there's another menu that you can right. So in here, once you go to network, right, there are some headers in here, right? So in here, when I go to headers under general, you can see the request URL, right? And you have to select all here as well, all here, right? All the links, all types of links are shown in here. So you can go to those, I mean, that tab, and from there you have to select headers, and then from there you can get these information. I hope it is clear, right? Right, so HTTPS, right? So HTTPS includes encryption, right? It uses encryption, all right? So encryption methods are defined for HTTPS protocol. So there are basically two encryption methods that are used by the HTTPS. So we call them SSL and TLS, right? So we have SSL method, we call that secure sockets layer protocol, right? So in that method, actually, we use a authentication certificate to verify the end device, and then we are actually using authentication methods to authenticate the data that is sent in a between two devices, right? So once we are accessing some web service, then the web service is sending us sending us data that they are authenticated device, and once we are sure of that, we are sending our data, right? So once we are actually using this SSL method, we are using actually usernames and passwords, right, at the end devices to ensure the uh, I mean ensure the reliability of data getting received at the correct person, So only the receiver and the transmitter, or the source and the destination, has the access to these username passwords, and also authentication certificates. They are the people who are able to retrieve the data at the once they receive the data at the destination. So the person who's sending data first requests some authentication from the end device, and the end device needs to send the authentication information back to the client, and then the client decides to send the data to the end destination device. So right, so based on this first authentication, they decide like how they are going to send the information and how they are going to encrypt and decrypt the data. And likewise, they will after first confirming that information, then they will send the data, right? So this is known as the handshake. So after doing the handshake, they are sending the data reliably in the second phase, where they uh, encrypt the data and send the data. So encrypt the data means they're changing the readability of the data, and they change it into a unreadable format, and they send the data. So only the person who's at the receiving end and who has the information on how to decode the data can decode the data. So in that manner, the SSL is used. And TLS is another method that is widely used, and currently TLS is the most updated or latest version that is used. So in HTTPS, TLS is the modern method of securing the data. So in there, actually, we are using the public and private keys, right? So for encryption and decryption. So in there, so the person who's sending the data, who's receiving the data, right, they will first do the handshake, right? In there, they will exchange something called public keys, right? Public keys, right? The public key will be exchanged, right? Even so, at that moment, right, the person who's receiving the public key will like will encrypt the data using that public key, right? So according to that previously decided method, the client is encrypting the data. So if he's sending the word cat or something, it is writing that data in a different manner according to its previous whatever the defined standard of previous determined method of encrypting, and it will write something very unreadable, right? So and then it will send the data, right? And then the person who's receiving this data, right, now he is the only person having the private key, right? So the intermediate person does not have the private key, right? He might also get the public key once he's tampering with the intermediate routers, but that person does not have the private key. So in order for that person to decode the data, that person needs the private key. So the private key is only held with the server, the person who's receiving the data. So in that case, only the server is able to decode the data and reliably transfer it to the word cat, for example. So the person who's intermediate does not have the information of the private key. It is not shared with even with the client, right? So right, I hope that is that was clear to you. So I mean, there's an intermediate person in here, so there's a server here and the client here. So once the server is exchanging data, so in between, if this person is accessing this server, right, the public key, which is public, will be shared with everybody. So this person also might have the public key. The reason, however, now this the client needs to send data back. And the client want to access the server. So once the client is sending the data, although the intermediate person is trying to decode that data, the intermediate person cannot decode that data because uh, that person does not have the private key, right? So actually that is something that is happening in TLS. So there's something called private key and public key, right? So that is the method of decoding data reliably using the TLS method. So those are the basic techniques used by HTTPS protocol to encrypt the data and secure the data transmission, right? So encryption is the method used to secure the data, basically. So I mean, using TLS, that is the method used. So in secure sockets method, they are using something called authentication methods, like Google authentication, for example, we can consider, right? The authentication, uh, must be, is a method used to authenticate the, device and access the web service. So each device need to have their unique IDs or passwords to access the website. So an intermediate person does not have that unique passcode or the password and the username passwords, right? So that person cannot access the website suddenly. So that is how the secure SSL method is used. So basically, a TLS method actually uses encryption. SSL basically uses the authentication methods. So actually, that is how it's done. So asymmetric encryption. Actually, I don't know whether it is known as asymmetric encryption exactly. I hope you can search about it more. Really, it is, I think, you can search about it with related to network security. So basic understanding was the one I discussed. So anyway, some kind of encryption is done. And it is used to secure the data. So encryption is the method used. So asymmetric or symmetric, I think you need to search about that, right? So advantages and disadvantages of using HTTP in IoT, right? So IoT, when we consider about HTTP, basically HTTP can be useful in situations where we are accessing websites using, our IoT network, right? In our IoT network, if we are constantly accessing a website, then we can use HTTP protocol, right? In situations where we have good network connection and we have good communication network resources, then we don't have any problem of accessing the network and updating our data into the website, right? For example, if somebody is monitoring some room temperature, for example, in an indoor area, right? That person can monitor the quality of air inside and then constantly update that into the website using HTTP, right? No problem with that. In that case, the person who's in the indoor room has good Wi-Fi connection, and the monitoring sensors have power supply and constant, like power supply is given to those embedded systems, and therefore this situation is having energy, or it's not a constrained environment. In that case, we can use HTTP method. However, in cases where we have remote locations, right, when we have sensors placed in remote locations, in paddy fields or in kind of difficult areas like underground areas or somewhere underwater areas where we cannot access daily and constantly, then we need to secure the power supply and the connection link of those sensors. In that case, we need to have lightweight protocols, and we cannot access, we cannot send a lot of data, and we cannot have energy draining. So once we are using HTTP, we require a lot of computation, and then also higher overhead, right? It comes with the complexity of HTTP. So for low power devices, it might not be a suitable protocol. In that case, we actually require other like simple protocols that that will uh, give us low latency and high throughput, right? So HTTP cannot give low latency and high throughput in situations where the environment is constrained, right? When the connection link is not that strong, and when the energy at the end device or the sensor based embedded device is not that high, then the HTTP protocol usage is not that useful, because it drains the end device's energy, and it's also uses a lot of communication resources, and therefore we cannot actually go for this very modern or like sophisticated protocols like HTTP. In that case, we need to use specific protocols for the IoT application, right? So in that case, we need to use protocols like CoAP, right? CoAP protocol is known as the Constraint Application Protocol. It was developed by the Internet Engineering Task Force, IETF, and it is designed for the direct M2M applications, right? That means machine-to-machine applications. So CoAP is the simpler version of the HTTP, and it is used to access web services, and it is much more lightweight than HTTP because it is built on lesser actually functions than HTTP. So it has lesser functions than HTTP, and therefore it does not waste or consume a lot of energy, and therefore it is much lightweight than HTTP, right? It is designed for constraint situations, right? So constraint environments can use this. When the sensors are placed in constraint environments, we can use CoAP to access the web services or edge routers, and from there we can access the internet. This is also using the request response model, just as HTTP. The difference with HTTP is that this is working over UDP. So I said earlier that HTTP was using TCP, which is a reliable communication protocol, right? In here, we are using UDP, user datagram protocol. So this is a connectionless protocol, which is an unreliable protocol. So in here, actually, we are trying to send data, but the data might get lost. In this case, some of the packets might get lost in between. So however, in the IoT remote monitoring case, we might have to expect losing some data once we are using this CoAP method. And in cases, it's okay actually to even lose one or two data. As I said before, if we are constantly updating the server about our data, then losing one or two data might not be impacting the total data collection at the server end, and also the customer might not notice it because the data keeps coming. And then this HTTP uses lesser resources, and also the CoAP protocol has no idea about the clients, right? MQTT protocol we talked about has idea about all its clients, right? The clients 1, 2, 3, and then all its customers 1, 2, 3. Likewise, it has a list of people who have published to a certain topic and who have subscribed to a certain topic, right? So MQTT protocol has knowledge about its clients and the clients which are connected to the broker. But CoAP does not have that much of knowledge. It is only sending the data towards its neighbors, right? Whatever the neighbors that are there in the vicinity, right, in the neighborhood or in the communication range, it is sending the data, right? The neighbors will receive the data, right? So it is a very simple method of sending data forward. Okay, so CoAP has basically 4 types of message types, right? So it is using uh, uh, con messages and non-messages and reset message, acknowledgement message, right? So in there, we have different ways of reacting to the received message, right? So as I said before, CoAP uses the request response model, right? So in here also we have, I mean, the get method, just like the HTTP to receive information, right? So so the get method is used to receive information, and once the get command is given, the person who's receiving that data is responding with the data that is requested. So the get method is applied over a certain IP address, and then the whatever the required information is requested, and then the person who's sending the data is sending that data in its payload and giving the response, right? So the request is sent and the response is received, right? So yeah, so this is the basic CoAP model. You're sending some message and some response is received, right? So under that scenario also we have 4 types, right? 4 types that can happen. So confirmable message type can be used to send the data, right? So we will actually see how, like once we are coding, uh, we can define what type of a message we want to send. So based on actually whether it's a con message, we can write con in here in the code. So once we select the con, then the message will be sent in that manner, right? So according to the con, I will explain about con, these 4 types later. So if we want non type, we can define that as well. And if we want ACK type, right, that means con with the ACK, we can define ACK in the message. So likewise, we can define, right? So the reset message also type is there. That is for resetting the communication link. If a communication link is broken at one end of the communication, right? If the client loses connection or the server loses connection, the communication is reset and the communication has to be restarted again. So so in the CoAP, I have mentioned there are 4 types of message types, right? So non-message type and con message type and reset and acknowledgement. So basically, once we take the non and con, right, message types, in there, non-message type means non-confirmable message. So non-confirmable message means that the client is there and it is sending some data, and it does not require any acknowledgement back. So basically the client is saying, I don't need a confirmation. You just receive my data. I don't need any acknowledgement. And then confirmable message means that the client is sending the data and the client is expecting an acknowledgement from the server, right? So the client requires an acknowledgement, right? So please confirm that you got my message, right? So in this case, the con message type and ACK message type both are used, right? In con message type, there are 2 message types that are used, right? The con means like you're sending the data under the con type, the server is sending the ACK type message. So in the next type, in this slide, I'm explaining about 2 scenarios that can happen under confirmable message type. right? In the confirmable message type, we can have two scenarios where we have this acknowledgement occurring at two different times, right? So the client is sending some data and requesting some data from the server, let's say, right? So the client is requesting pressure data from the server. The server is sending the pressure data back to the client. So it is sending it as an acknowledgement message, right? And then in the second scenario, the client is sending a request for pressure data from the server, and the server sees that it does not have the pressure message at that time. It does not have data about the pressure at that time. So therefore, the server is sending an ACK message type with no information about the pressure, just an empty ACK message. And then the client knows that the server has received his request, and then client is waiting, and then server is waiting for some time until it gets the pressure data, and once it gets the data, it sends the data via a con message type. And then the acknowledgement message is sent by the client saying that it has received the data reliably from the server, the pressure data. So these are the two scenarios that can happen with the CoAP con message type. So either the server can immediately respond to the request, or otherwise the server can send an empty message saying, I will send you the data. So it will send just an empty message, and then later it will send the data that was requested using a con message type. So the con message type means the server is expecting a request back. So the client needs to send an acknowledgement message back to the server at that case. So the CoAP method can be used in situations that we have one-to-one communication, right? That means from one device to device, we can use CoAP communication, or else we can also use it for many-to-one or one-to-many communications, right? So CoAP can be used for one-to-one communications, right? If there are only two devices in the communication range, so there's only one-to-one communication, right? If the source only want to talk to another, destination one device, a single destination device, then one-to-one communication is there happening. And then we have in some situations where the source wants to talk to multiple devices. So in that case, one-to-many communication is happening. So in that case, once the communication, messages are sent to the destination, whatever the devices or the server has to respond back to each of the messages received with its own separate message, right? So, or also, this could be the case where we send the source to several servers, right? We can send to several servers our several requests, or the same request we can send to several different, we can request the same resource from different servers, or we can actually have one device requesting multiple devices requesting services from the same server. So in that case, we can the server will respond to each request with separate individual message, right? So CoAP basically has one-to-one communication, many-to-one communication, right? Or one-to-many communication, and so on, right? Uh, uh, wait. Okay. Where's- Okay, so this is a comparison between CoAP and HTTP methods. So uh, we can compare the how they are using, I mean, which protocols they are using and what kind of method they are using. And we can see like how HTTP differs with the CoAP. So basically, CoAP is a lightweight protocol, and it is using basically like very simple methods to transfer information to its neighbors, right? So therefore, it is using UDP protocol, and basically it is a connectionless protocol and unreliable protocol. uh, However, like it is anyway using UDP protocol to transmit data, which requires less like complexity and less like it is more lighter than TCP, right? So therefore we can actually we can have UDP in the CoAP, and then in HTTP we have TCP method. So we want reliable communication, and therefore we use the TCP protocol. And then we in the when we talk about the message encoding, we use the binary encoding in the CoAP, which conserves resources. So we convert the data that we collect from the sensors, for example, into binary format, and then we are sending in the binary format to the other devices. So the data is sent using binary format, so that we actually don't have to do much computation at the intermediate devices. And also it is very easy to transmit the binary encoded data compared to the text-based encoding data, where we need to include a higher payload and resources. So text-based encoding requires higher payload and resources, and therefore text-based encoding uh, is much more sophisticated, and therefore it cannot be used in IoT communications. So binary-based encoding is much more preferred and simple in complexity when compared to the text-based encoding. And then once we concern about the request methods used, so CoAP uses the get, post, put, delete request methods. So HTTP also uses those four methods, but it has more functions than those four methods. It has more other methods as well, and therefore it uses more complex functions, and therefore it requires more resources, and like it has more complexity. In terms of applications where we can use these protocols, CoAP can be used in constrained environments because of its lightweight and reduced complexity, and the HTTP is used for general purpose applications. So when we talk about CoAP and MQTT protocols, right? So we have in MQTT protocol, we have this, reliability of data transmission, right, than CoAP, right? So once we are using this MQTT protocol, therefore we have higher power consumption, because mainly we are doing more communication between our clients and our broker, right? There's a broker in between the clients and the receivers, right? All our clients, so they can be the publishers or subscribers. So the communication has to be done in between the broker. So the broker needs to be in between the communication. But in CoAP, we only need the person who's sending and only the person who's receiving the data. So there's no in between like server or like in between device to do the organizing of the data and publishing, or keeping a track of the communication that is happening. So therefore, in terms of power consumption, the MQTT protocol has higher power consumption than the CoAP protocol. So transport protocol, we don't have so transport protocol, we have a TCP protocol under MQTT protocol is built over the TCP protocol. So as I said before, the transport protocol is defined basically based on the application that we are using. So the application layer protocol is the MQTT protocol. So if we are using the MQTT protocol, that means the application or the user requires higher reliability of data. In that case, the TCP protocol is used. So because the user wants more reliable data, TCP protocol is used. But in this case, the user does not need more reliable data, but the user need very, efficient data. Very frequent data. Therefore, it uses UDP, which is connection less protocol, and might lose some data packets. But in that case, anyway the data packets will be received with high frequency than the MQTT protocol, TCP protocol, right? So in that case, because of that, UDP protocol is used in the CoAP. And then we have the publish subscribe model for communication. So in MQTT, so there we have the publishers and subscribers. And then in the CoAP method, we have request response method. So there's a person to request a resource, and there's there's a request response model. So we are sending a request and we are receiving a response from the server. So that is the difference between the communication models. Then once we talk about the connection models, we have M2N communication. That means any number of devices can communicate with any M number of devices can communicate with any N number of devices in MQTT protocol, right? So it's a very flexible number. We can add or remove any number of devices, and we can have any number for these two sites, right? If we are going to scale the IoT system, we can scale it in the way we want. However, in CoAP protocol, we can either do one-to-one, N-to-1, or one-to-N. That means we cannot have M-to-N communication, but we can actually do N-to-1. That means multiple devices can communicate with one server, right? So the one server can communicate with multiple devices and so on. So CoAP has that kind of a connection model, so it cannot have the M2N communication, right? So another question that is asked is that, like, are these MQTT CoAP, right, unencrypted? So that is the main problem with the IoT networks, right? So IoT networks are facing this challenge of security, right? So we don't actually currently have encryption methods basically defined for these MQTT and CoAP protocols, basically, according to my understanding, right? So the main reason is that it adds a lot of complexity for the communication, right? So once we add the encryption, decryption, those methods, it adds a lot of complexity to the communication, right? So in IoT networks, we are actually going for scenarios where we have remote environments, and we need lightweight communication to communicate with the server, right? So in that case, we don't have much more processing at the end devices, right? So however, like now as I understand, according to my knowledge, now actually research works are done about these edge devices and how we can secure the data at the edge devices, right? And how we can send the data more securely to the local server in an IoT network, right? So IoT networks are all about reducing the cost, right? Reducing the resources that is used, right? So in order to achieve that goal, right, it's kind of difficult to achieve that goal with a lot of computation at the end devices, right? So the end devices are resource constrained devices, right? So therefore, encryption, decryption, those secure methods uh, are yet to be implemented in a very I mean, stable manner, right? So you can actually research about this. I think it is a very good question. So one thing, I mean, that I need to emphasize is that the main challenge that we have in IoT networks is the security. So I will be discussing about the security in a separate, separate lesson and a unit, or some some kind of a part of a unit, where we will be talking about the challenges that the IoT networks are facing as of now, right? So in terms of security, right? So that requires uh, right? So currently a lot of research work is going on that, right? So CoAP actually works with the, I mean, one-to-one communication, as I said. So once it is, like, for example, if it is not connected to the web server, it is using, it is doing the communication with the intermediate, I mean, device, right? Could be another device, right, which is connected to the server, right? Until we reach the server, right? This could be the edge router, right? So the edge router, right? Until we reach the edge router, we will be communicating with the CoAP protocol, right? So each of these devices will communicate using the CoAP protocol until we reach the edge router. And once we reach the edge router will communicate with the server using the HTTP protocol, right? So until then, we are using the CoAP protocol. So in CoAP protocol, the person who's sending will act as the client, and the person who's receiving will also be a client. Actually, it is not the person who's giving the web services, but it would be an intermediate client or intermediate device, a relay, for example, and then it is will be going through multiple hops, and then it will reach the web service. I hope it is clear to you. If you have questions, you can let me know. So once we compare with uh, for IoT systems, once we consider the MQTT and the HTTP, CoAP protocols. So if you ask what is the best protocol for the IoT networks, actually the answer will depend on the application, right? The application in which these protocols are used, right? So if the application requires reliable message delivery with minimum code, then we can use for MQTT. Then CoAP, right? CoAP is using instant messaging and with low latency and low energy. In that case, we can actually go for CoAP, where we need instant messaging, so low latency. For low latency scenarios, we can go for CoAP. For reliable messaging, we can go for MQTT. So depending on the application, we can use either MQTT or CoAP. So we cannot say this is the best protocol all the time. So we need to consider the application in the application we are using it on. as of now, CoAP does not have the QoS levels, according to my understanding, my knowledge, right? So CoAP is not that like complex protocol, right? It is only just using to like forward the message, right? It is not using any acknowledgement messages, right? So therefore, QoS levels are not defined for the CoAP. Apart from that, once we take the CoAP and MQTT protocol, we can see that the popularity for the MQTT is higher than the CoAP, right? So in the Google Trends, once you search for it, you can check that, right? So MQTT has much more popularity than the CoAP in general. So once it is used in applications, MQTT is much more preferred because it's having much more stable communication. So anyway, CoAP is also having some kind of popularity. So anyway, the MQTT protocol, once you are searching, we can see actually that it is the kind of the standard protocol that is proposed for the IoT. And then we can go for the next protocol that we are discussing today, the last one, which is the WebSocket protocol. So the WebSocket protocol is the protocol that is used for applications such as online games, chat applications, and so on. So in this case, we will be receiving two-way communication, or we will be conducting two-way communication, and we will be receiving messages, I mean, instantaneously from the server and from the client. So in this method of communication, there's a client and a server, right? So the client is accessing a server, right? First, it will establish the communication, and then once the communication has started, it will, after the handshake, the data communication will start, and the data communication will not be closed until the one of the client or the server decides to end the communication. Right. So in here, in the data communication time slot, the communication will stay for a long time. So long-standing communication will be there. The communication will not be closed. So, and also the communication will be bidirectional. So the person who's typing a message on the chat will after it is sent, the server is sent, will see that message, and so on. I mean, once the server types something, the client will see. So likewise, bidirectional communication will be occurring, and in this WebSocket communication, right? So we will actually see an example scenario in the in this website. So in here, we can actually type something. So this is a website which is allowing chat applications. So chat applications give us some kind of a response back. So we can actually inspect this website, right? Can go to network, and then in here, in order to see the WebSocket application, because it is a special one, it is available in the WebSocket, option in here, right? So I need to refresh this in order to see the WebSocket protocol appearing in here. So once I press something, I will get some, outputs from this window. So in here, we have the WSS, protocol used, which is the WebSocket protocol in use. So we can see that I have used the WebSocket protocol in here. So we can actually see likewise for chat applications that WSS protocol has been used. So that is how it is available in the websites. So those are the basic protocols, application protocols that I wanted to discuss under the application layer. So if you have questions, you can let me know. And yes, so apart from that, we can also go ahead and go ahead to the tutorial. So before that, do you have any questions with regard to the project? So the, I mean, any kind of content related questions. Do you have any questions? If you have, can put in the chat. Right. What do you mean I have scheduled an interactive session? So actually I'm doing interactive session in for you, I mean students, I'm doing both the interactive and the lecture online, I mean content lecture in the same like 2 hour period. I think, I mean, I'm only discussing about the interactive session classes. I think I was talking with the regular students. Okay, so for them, I'm having on like Thursdays and Tuesdays. So you don't need to be there. So I will be doing the interactive session in here in during these times, right? So yes, assignment 3 I have given in the LMS, right? LMS, I have given assignment 3, which is possible for you to do, which is regarding MQTT protocol and which is regarding the coding there. So you can actually do that. Even last week, I think you can actually attempt it. It's a, I think the content has already been done for that. So you need to adjust the code and code which is given, and you need to adjust according to the, I mean, question that I have given, according to the data I have given in this question. You need to adjust some parameters or something in the code, and you need to submit that. So it can be done by you now. I have covered the content regarding that, so you can do that now, right? So basically, that is that. And apart from that, I, I have not given any other assignment. And this is the interactive session that I have conducted already, right, for the regular students. So I will also go through that with you. So this is the tutorial question that I would like you to attempt. So I have already uploaded this in the LMS, but you can also, I mean, I will upload this, I mean, I think you can also refer the already uploaded one in the LMS. Anyway, the question is this, and this is regarding how we can design an IoT network system for a smart agriculture application, right? So in this case, I'm asking about farmers facing number of challenges, including weather conditions, pest attacks, soil degradation, and like uh, some kind of crop quality, and then how IoT technology can be used to address this challenge, right? And then what are the sensors that you can use, right? You have to suggest some sensors that you can use with the examples. So you can mention the type of sensors that you can use for different measurements, right? Temperature, humidity, soil moisture, and so on. And what are the example modules that you can use that are available in the market? For example, you can mention the names of the modules, right? Apart from that, I'm not asking about the pest detection and prevention in here, mainly because it requires image processing and detection based on that. So rather apart from that, I'm asking basically about how you're going to measure the temperature, humidity, soil moisture, right? And so basically that is for the first question, that is how I'm requesting the answers. And then next I'm asking like the target field area, the paddy field, let's say, it's within 1 kilometer from the farmer's location. And then if we are going to use communication technologies, what type of communication technology you're going to use? Out of these technologies that are mentioned, what is the best technology for your for that application, and why do you suggest it? So you need to justify that. And then once we are actually concerning that the paddy field is a constrained field environment, then what is the network layer protocol that is optimal for this scenario, and why do you use that protocol? Right, so several network protocols we learned. So basically we learned that 6LoWPAN was a very good protocol for the constraint environments. So you can consider that, and you can justify why you are using that 6LoWPAN protocol, and why it is specifically used for IoT applications. And then we are talking about the application layer protocols that we'll be using for this application. So we can use either MQTT protocol or CoAP protocol, right? So because we are concerning about constraint protocols, constraint environment protocols, we can use MQTT and CoAP protocols. So out of those, what is the best one? That is what I'm asking. So based on this requirement, you need to choose the best one. So the farmer is preferring low latent communication over high reliability. So the farmer is saying he wants low latent data. That means he needs frequent data. Then he doesn't need high reliability much. Because of that, you need to decide what is the best protocol based on this requirement. Right, and then you need to define which protocols are used for this application by you under these for each these protocol under these protocols. Right, what are the protocols that you're using under these layers? So you need to define those protocols, right, for this specific application. So you can't mention multiple protocols, just only the protocols that you are using under each layer you have to mention. And then what is the total overall view of the IoT system that you propose with all relevant components? So you can mention all the relevant components used in your IoT system and label each of the components clearly. Okay, so that is what I'm asking from this question. So I'm not giving this as a assignment, right? You can test this out. So one thing I must say is that tutorial sessions might be very important, because I will relate this closely with the exam questions, right? So therefore try these things out and try to write answers to these questions, and similar question will be coming to the exam, right? So in the exam, actually I will not ask about the exact modules available in the market, but you might need to know whatever the sensors that are available, like temperature sensors, PIR sensors, or light resistant, LDR sensors, and so on. And so these types of sensors you need, and why they are used for, you might need to know like a little bit, not to a very complex level, right? So you might need to know that there are some sensors available to measure those whatever the parameters, right? And then about the communication technologies and their abilities, their communication range, their data rates, or their power consumption, that you might need to have a knowledge about. So that is all for the interactive session. So you can try these questions, and you can inform me about if you have any questions. So do you have any questions? If you have, you can let me know, and I will just ask you to do this, so you can do it in your free time, or right now you can do it, right? So from next week onwards, I will actually be going in parallel with the regular students. So therefore, there will not be any deadline changes for you and the other students from next week onwards. So we'll be continuing like that.